Hello Math 130 students, we will pick up on page 10, section 7.4, graphing quadratic functions. So we already know that the general equation of a quadratic function is of the form ax squared plus bx plus c. Well, the other thing that we know is that it looks like a parabola. So a parabola can either be a positive parabola. So this graph here is of a positive parabola. And this one looks like a negative parabola. And the way I always kind of think about it is that positive parabola, it looks like somebody is smiling at you, versus this negative parabola, it looks like somebody is frowning at you. So positive smiling, negative it's a frown, okay? So that is going to determine whether or not the parabola is going to open upward or downward. And it's all about that leading coefficient A. So here, this is opening up upward, and this is downward. The vertex is going to be either the minimum or the maximum point on the curve. And so we can see that this parabola, it's symmetric. So if I were to draw a line right down the middle through the vertex, we can see that this left-hand side is exactly the same as this right-hand side. So we say that it's symmetric, okay? The axis of symmetry can also be found using this formula of x is equal to negative b over 2a, which can also help us to find the vertex, okay? So here is another form that it can be written as. So before we talked about, having y is equal to ax squared plus the bx plus c. Well, now we can also have it in the vertex form, which is the a parentheses x minus h squared plus k. And it gives us that the vertex is at hk. All right, so let's really dig into this. So here, it says determine whether parabola is opening upward or downward. So remember, upward means it's going to be a positive parabola. And downward means it's going to be a negative parabola. And it really comes down to that leading coefficient. Is your a positive or negative? Well, let's look at number 1. For number 1, I can see that my a value is equal to a negative 9. So I'm going to say that this is going to open downward, since this is a negative parabola. Here, that leading coefficient, that a value is really a 1. So I have that my a is equal to 1. That is positive, so that's going to be opening up upward. For number 3, again, we are looking at that a value. A is equal to a positive 4, so that's going to be upward. And for number 4, we see that as a negative 2. That's negative, so that's going to be opening up downward. Okay, so remember, opening up upwards or downwards really just corresponds to that a value, whether it's positive or negative, okay? Now, for the next example, it wants us to find the axis of symmetry and the vertex for the parabola. So remember that this vertex, it's a special ordered pair, where I have my h value and my k value. And it's either the minimum or the maximum point on the parabola, depending on whether or not it's going to be an upward or downward facing. So here, that vertex would be that minimum point or that maximum point. And the axis of symmetry is going to be that line where it's symmetric on both sides, which really just represents this h value. So the equation to find h is negative b over 2 times a. So here I have a is equal to negative 4, my b is equal to 32, and my c is equal to a positive 10. So when I plug it into this formula, well, the b value that I'm plugging in is 32, and the a value that I'm plugging in is a 4. So now I'm just going to plug that into my calculator. So I have a negative 32 in the numerator, and I have a negative 8 in the denominator. So a negative divided by a negative is a positive. So now I have that my h value is 4. So for my vertex, remember I need the h and the k value, where I at least know that the h value is 4. To find the k value, plug it into your original equation. So to plug it into my original equation, I have y is equal to a negative 4 x squared plus 32 x plus 10. So that value that I'm plugging in is h is equal to 4. So now I'm going to have negative 4 times 4 squared plus 32 times 4 plus 10, which gives me a positive 74. So that tells me that my k value is equal to a 74. So now when I write the axis of symmetry, I'm going to say the axis of symmetry is going to be x is equal to my h value. That h value is 4. So that is how I worked out number 1. Number 2 is very, very similar. So again, I have my h is equal to a negative b over 2a. And here it looks like a is equal to 1, b is equal to a negative 10, and my c is equal to a negative 8. So that b value that I'm plugging in is a negative 10, and the a value that I'm plugging in is a positive 1. So I'm going to get that h is equal to a positive 10 divided by 2, which gives me a positive 5. So my vertex that's written as an h and a k, I have a positive 5. And now I have to find my k value. So I'm going to plug it in. So y is equal to x squared minus 10 times my x minus 8. And that value that I'm plugging in is 5. So now I have 5 squared minus 10 times 5 minus 8, and that gives me that y is equal to a negative 33. So my k value is a negative 33. So now I have my vertex. So now I'm going to say that the axis of symmetry is going to be, and you always have to write x equals, and now you're going to input that h value. Here that h value is 5. And so that is how I found the vertex and my axis of symmetry. So once you find the vertex, you already have your axis of symmetry, right? It's just that h value. Now it says graph the parabola by plotting 3 points on the parabola. So okay, Well, I know that this is my general equation, so I have my x and my y value that I'm going to be plugging in. A good value to always start with, I think, is a 0 for your x value. And let's do a 2 and a -2. So we're going to be plugging that into our equation. So we have y is equal to a negative x squared minus 3. So let's see what happens when we plug in a 0. Well, when I plug in a 0, 0 squared is just 0. Minus 3 is a -3. So I have 0, -3. So now let's try our +2. So I have negative parentheses 2 squared minus 3, and that gives me a -7. Now let's try our -2. So negative parentheses -2 inside parentheses squared minus 3, and that also gives me a -7. So there are some 3 points. So let's see what I get. So I have 0, -3. I have 2, -7. And I have -2, -7. So my graph more or less is going to look like that, okay? Now I'm going to do the exact same thing for number 2. So I'm going to have some values that I'm going to plug in for my x and y. And like I said, 0 is always a good number to try. Let's see what happens when I plug in a 0. So here I have y is equal to a 4 x squared minus 5x plus 38. So the first thing I'm going to plug in is a 0. Well, if I plug in a 0 in, well, 0 times anything is just 0, and 0 minus 0 is just 0, so I'm going to get a positive 38. So that is a very big number, so it's not quite on my parabola, which is fine. So let's try to look for some easier numbers here to plug in. So if I, let's say, plug in x is equal to a +1. Well, when I plug in a +1, I get a 37. So let's see what happens when I plug in a -1. So if I were to plug in a -1 and plug that into my calculator, I get a positive 47. So these are some very big numbers, and that's okay. That just means that my graph really should have had bigger numbers. So really I have a 0, 38. So let's just say our 38 is over here. So then 1 and 37 should be right about here, and -1 and 47 should be around here. So more or less, this is where our graph should be looking like. And of course this isn't perfect because the graph that was given to us was a little too small. So for the next example, it says find the x and y-intercept of the parabola. So remember, to find the y-intercept, that is when you let the x value equal to 0. This should be familiar from when we had linear equations. So if I have y is equal to a -8 plus 16 minus 8. And so now I'm plugging in 0, so I get that y is equal to a -8. So now I know that my y-intercept is a 0, -8. And make sure you write it as an ordered pair. Now, to find the x-intercept, that is when you let your y equal to 0. So if you're going to let your y equal to 0, you're going to have 0 is equal to a negative 8x squared plus 16x minus 8. So how can we solve for this degree 2 polynomial? Well, we can factor. If that doesn't work, we can always do the quadratic formula. Or for people who prefer the completing the square, that's fine too. So we have 3 really good methods, and it really doesn't matter which one you use, just choose one. Let's just go with factoring. If I were to go with factoring, I would do the GCF. My GCF here would be a negative 8. When I factor out that GCF, I would have an x squared minus 2x plus 1. So now, when I factor, I would have this as a negative 1 and a negative 1, because negative 1 plus negative 1 is negative 2, and negative 1 times negative 1 is a positive 1. So now, if I set each thing equal to 0, well, negative 8 is equal to 0. That doesn't work. X minus 1 is equal to 0. So x is equal to a positive 1. So that tells me that the x-intercept is going to be 1, 0. Okay, well, let's try that again for number 2. So for number 2, if I'm trying to find the y-intercept, remember we let the x value be 0, so it kind of just cancels out. So I get that y is equal to 20, so my y-intercept is 0, 20. And that would be your y-intercept. And remember, that's because you let your x equal to 0. Now, let's think about the x-intercept, where you are going to let your y value equal to 0. So I have now 0 is equal to a 2x squared plus 9x plus 20. Here I do not have a GCF because 9 has 3 as its factor. It's not divisible by 2. So you can either do the AC method or you can do guess and check. I'm going to go ahead and go with guess and check. So I have 2x times x. So I just took a minute to look at my factors of 20. I have 2 times 10 and 4 times 5. The 2 and 10 I can't use because that's a 2. And if I have 4 and 5, I'm forced to put the 4 here and the 5 there. But then that doesn't add up to a positive 9. So what this tells me is that even though factoring is a good method, sometimes you can't always factor. So instead, I'm going to go with the quadratic formula. So this did not factor. So instead, I'm going to go with my negative b plus or minus the square root of b squared minus 4ac all over my 2a. And so I have that my a value is 2, my b value is 9, and my c value is 20. So I have a negative 9 plus or minus the square root of, and this is where I'm going to use my calculator. So I have a 9 squared minus 4 times 2 times 20. That gives me a negative 79. And now I have 2 times 2, which is a positive 4. So now I know that my x-intercepts, I'm going to have an imaginary number because I have an I there. So this really becomes my negative 9 plus or minus I square root 79 divided by 4. So the way I'm going to write that for my x-intercept is going to be negative 9 plus I square root 79 over 4, comma 0, and negative 9 minus I square root 79 divided by 4. So that ends up becoming my x-intercepts. My x-intercepts here become imaginary. So I have imaginary x-intercepts. Okay, well, let's see what happens with number 3. So again, I'm going to go ahead and start off with my y-intercept. I think that's a little bit easier. And that's when you let the x value equal to 0. So here I'm going to have y is equal to, well, if that's 0, it cancels out. If that's 0, that cancels out. So you have a positive 1. So my y-intercept is 0, comma 1. Now I want to think about the x-intercept. That's when you let your y value equal to 0. So you have 0 is equal to a negative 2x squared minus 5x plus 1. Well, I already know that this is not going to factor, so I'm going to go ahead and go with the quadratic formula. So I have a negative b value plus or minus, and I have 2 times my a value. So that b value that I'm plugging in is a negative 5. So now inside my parentheses, negative 5 squared minus 4 times your a, which is negative 2, times your c value, which is a positive 1, and you get a positive 33. And remember, 33 I got by b squared minus 4ac, right? The discriminant there. And of course that a value, like I said before, was a negative 2. So I'm going to have that x is equal to a positive 5 plus or minus the square root of 33 all over negative 4. So now my x-intercept, I have 5 plus the square root of 33 over negative 4, comma 0, and 5 minus the square root of 33 all over negative 4, comma 0. And those become my x-intercepts. Okay. Now, for the next example, it says graph the parabola by plotting the vertex, x-intercepts, and your y-intercepts. So remember, if I'm trying to figure out that vertex, the best way to remember that is h, comma k, and the h value is found by negative b over 2a. We did that earlier. I'm just going to write that a little bit better. I can't write that b very nicely. There we go. Okay. So now that I know that, I'm going to use that for number 1. So here I have that my a is equal to 1, b is a negative 6, and c is equal to a positive 8. So if I'm trying to find my vertex, that h value, negative b over 2 times a, I have a negative, and that b value that I'm plugging in is a negative 6, and the a value that I'm plugging in is a positive 1. So I have a positive 6 in my numerator and a positive 2 in my denominator, which gives me a 3. So now I know that this vertex has 3 as the h value. So now I'm going to plug it into my original equation to find my k value. So I have y is equal to x squared minus 6x plus 8. And that value that I'm plugging in is 3. So I have a 3 squared minus 6 times 3 plus 8, which gives me a negative 1. So now I know that my vertex, I found that, and it's a 3, negative 1. So there is my vertex, 3, negative 1. Now it says to also graph the x-intercept and the y-intercept. So if I am looking for the y-intercept, that's when I let the x value be 0. So if I'm plugging in 0 now for the x, I get a positive 8. So I have 0, comma, positive 8. So that is my y-intercept. Now the next thing I need to find is my x-intercept. And that's going to become from letting my y value be equal to 0. So 0 is equal to an x squared minus 6x plus 8. So here I have x times x. For my 8, that would be 4 and 2 if they're both negative. So x is equal to 4 and x is equal to 2. So now I have that my x-intercepts are 4, 0, and I have 2, 0. So those are now my x-intercepts. So if I have 4, 0 and 2, 0. So my graph, you can think of it as more or less looking like that. Now we're going to do the exact same thing for number 2. And I'm going to have a little bit more room if I work over here. So I'm going to think about that h value as a negative b over 2a. So here so that a value is a negative 1, the b value is a positive 2, and the c value is a negative 3. So I'm plugging in 2 for b, and I'm plugging in a negative 1 for my a. And that got a little distorted. So a is equal to a negative 1. There we go. A little bit more space. So this is going to give me a negative 2 in the numerator and a negative 2 in the denominator. So I end up getting 1. So for my vertex, I get a positive 1 for my h value, and I plug it into my original equation to get my k value. So I have y is equal to a negative squared plus 2 minus 3. So that value that I'm plugging in is 1. So using your calculator, negative parentheses 1 squared plus 2 times 1 minus 3 gives you that y is equal to a negative 2. So your k value is negative 2. So now you have 1, negative 2 as your vertex. Perfect. So now let's look at that y-intercept. Remember, the y-intercept is when you let x equal to 0. So if you have y is equal to a negative x squared plus 2x minus 3. Well, x equal to 0 kind of cancels that out. So then y is equal to a negative 3. So then your y-intercept is a 0, negative 3. So that's there. So the next thing you really want to find is your x-intercept. So that's when you're going to let your y value equal to 0. So you have 0 is equal to your negative x squared plus 2x minus 3. If I attempt to factor this, I'm going to have a negative 1. So I have an x squared minus 2x plus 3. So I have x times x, which is x squared, 3 times 1, which is 3. If I want a negative 2, it would be a negative 3 and a positive 1. So that does not factor correctly. So I tried to factor, and I realized that was going to be my best bet at factoring. But when I FOIL it out, -3 times 1 is not a +3. So it does not factor. I tried it. So now I'm going to do -b plus or minus b squared minus 4ac all over my 2a. So this is where I do the quadratic formula. So I have my -b plus or minus my b squared minus 4 times my a times my c all over 2 times my a value. So now that b value that I'm plugging in is 2. The a value that I'm plugging in is a -1. And the c value is a -3. So I have this as a -2 plus or minus. Now I'm going to deal with the discriminant. So 2 squared minus 4 times a -1 times a -3 gives me a -8. And it's all over -2. So if I were to split this, it would give me -2 over -2 plus or minus, and since it's a negative inside, I have an imaginary number, and I have the square root of 8 over -2, which would just give me 1 plus or minus, and the square root of 8, well, that can be simplified as 2 root 2 and of course the 2's can cancel, so you have a 1 plus or minus I square root 2. And with that -1, I don't really need it because I have that plus or minus already. So these are going to be the x-intercepts. So I have a 1 plus I square root 2, 0, and 1 minus I square root 2, 0. And so since it's imaginary, we don't really worry about graphing those imaginary numbers. So at the very least, our graph, and since it's symmetric, is going to look like this. But I still have to find the values of those x-intercepts. Okay. Well, I hope that makes sense. If not, you guys can email me. Now we're going to deal with our word problems. So it says determine the minimum or maximum of a quadratic function and use it in applications. So for example, a landowner is planning to build a fenced-in rectangular patio behind his garage. Using his garage as one of the walls. He wants to maximize the area using 80 feet of fencing. The quadratic function gives the area of the patio, where x is the width of one side. Find the maximum area of the patio. So here, I want to go ahead and draw a picture. I think that's going to help me to understand. So the shape here is a rectangular patio. So at the very least, I can draw a rectangle. And that's about the best rectangle I can draw right now. And it says, using his garage as one of the walls, he wants to maximize the area using 80 feet of fencing. So fencing, that word right there, you want to think about it as the perimeter. So I have that my perimeter is equal to my 80 feet. I also have my area, A of x, is equal to x times 80 minus my 2x. And that gives the area of the patio, where x is the width of one side. So x is equal to my width. So the reason I give you that perimeter is because you want to be figuring out what this does. So first, I know that I have a width, right? So this is width And over here, I have my length. So I have length and I have width. And I have 80 feet of fencing here. So for my area, I can distribute this for my area. So my a of x is now equal to 80x minus my 2x squared. And so from here, what I want to do is I want to rewrite this in standard form. That just helps me. So a of x is equal to a negative 2x squared plus 80x. It helps me to visualize the equation a little bit more, so I know that I'm dealing with a quadratic. So now that I'm here, if I am trying to maximize the area, well, that word maximize, you should be thinking about the word vertex. So if you're thinking about the word vertex, then you know that you need your ordered pair h, comma, k. And remember that the h is found by negative b over 2 times a. So here my a value is a negative 2 and my b value is a positive 80. So when I have h, I have it as a negative b over 2 times my a value. So I'm going to plug in 80 and a negative 2. Well, if that's the case, my fraction in the numerator I have negative 80. Down at the bottom, the denominator, I have a negative 4. And so when I simplify my fraction, I get a positive 20. So my vertex, I have 20 for my h value. So now I need to find my k value. So for my k value, I am going to plug in that 20 into my original equation. So my a of x is equal to a negative 2 x squared plus 80 times my x. So that value that I'm plugging in is 20. So I'm going to get that I get my area is equal to 800, or better yet, your k value. So now when it talks about the maximum area of the patio, well, here remember that x value represented the width and the k value, the output, represents the area. So here my area is going to be my 800 feet squared. Okay. And that's going to be my answer. Now for number 2, it says a ball is thrown vertically upward from the ground with an initial velocity of 122 feet per second. Use the quadratic function to find how long it will take for the ball to reach its maximum height. And find the maximum height. Round your answer to the nearest tenth. So it already gave me the function, which is really nice. So we definitely want to use this function that they gave me. They gave me that h of t is equal to a negative 16 t squared plus 122 times t. And that plus 0, you can write it or not write it. If you add 0 to anything, it doesn't really change the value, so I don't really need to write it, but if you want to, that's fine. Now, the question it's specifically asking us for is, it says, how long will it take for the ball to reach its maximum height. So remember, when we're thinking about maximum height, we want to think about the vertex. So if that's the case, remember our vertex, you can think of it as h comma k, and h is found by negative b over 2a. And so here our a value is a negative 16, and my b value is 122. So in my calculator, I have negative 122 in the numerator and 2 times a negative 16 in my denominator. And that's going to give me a 61 over 16, which is 3.8125. So my vertex, that h value is 3.8125. And now I have to find that k value. I don't know what that k value is, but I know how to find it. And that's by plugging it into my original equation. So h of t is equal to a negative 16 t squared plus 122t. So that h value that I'm plugging in is either the decimal or the fraction. It doesn't really matter. And just for now, to save room, I'll just put in the fraction. So I can plug it into my calculator very nicely. And so that gives me the fraction 3721 divided by 16, and the decimal approximation is 232.5625. Okay. So how long will it take for the ball to reach its maximum height? And then find the maximum height. Round your answer to the nearest tenth. So if I'm thinking about the nearest tenths or nearest tenth, I'm thinking about decimals. So if I have, let's say, 3.8125, the tenths place is here. So that 1 tells me how I'm going to be rounding. So it's a 1, so I'm going to just cut it off. So I have a 3.8. So my answer is going to be 3.8 seconds to reach its maximum height. And then what is the maximum height? Well, the maximum height, so maybe I'll represent this as my h value. So h represents my time, and my k value represents the height. So I already have this as 232.5625. So that tenths place is here, which is a 5. So it tells me if I'm rounding to round up. So I'm going to have this as 232.6, and this is going to be feet. That'll give me the maximum height. Okay? And it says to find the maximum or minimum of the function. So if I'm asking for the maximum or minimum of the function, then it's asking me for the vertex, and in particular it wants the k value of the vertex. So first, in order to get the k value, I need to find the h value. So I know that h is equal to my negative b over 2 times a. And here my a value is negative 9, my b value is 0, and my c value is a 16. So the b that I'm plugging in is 0, and the a that I'm plugging in is a -9. So that gives me that h is equal to 0. So then my vertex, I have 0 for my h. Now I need to find my k value. I just need to plug it into my equation. So y is equal to a -9 x squared plus 16. So that h value of 0 I'm plugging in. So I get that y is equal to a 16. So here and what type of, is this going to be a maximum or a minimum? Well, let's think about this. If I have the function y is equal to a -9x squared plus 16, then I know it's opening downward because it's a negative a value. So it's opening downward. And so I have here, well, that point is going to be a maximum. So now I can say that the maximum value is going to be 16. And just over to the side, in case you were wondering, if I were to have a positive parabola, then this vertex here would have been a minimum. So it just depends whether or not you have a happy positive parabola or a sad negative parabola to determine whether or not you have a maximum or a minimum. Okay, and that is the end of section 7.4. If you guys have any questions, please email me or the Math Success Center or our tutor. Thank you.